Hey guys, it's Eric here, back again. Hope you can see this. I got a little different setup here, some new markers. I don't know, we'll see how these go. So I want to take up a couple of some of the homework, and I'm just going to take up two. The first one's going to come from Unit 3, Handout 10, and it's going to be number 6, and we're going to see if we can figure this one out. So you'll notice that this is an RL series circuit, a little different than some of the other ones because I haven't given you R and XL. Instead, I've given you a couple of voltages and a current here. Doesn't matter, we can still figure it out. This is the resistor here, so this must be ER. This is the inductor here, so this one must be EXL. Now, because I haven't given you any ohms values, we're not going to do it the traditional way, which is to calculate it using a impedance phasor diagram. What we're going to do is draw a voltage phasor diagram because we know that the sum of these two voltages should equal the total circuit voltage, which is E total. So that's what we're going to calculate first, and I'm going to draw these phasors. I'm going to draw ER. So here's my little world here. There's my current. I'm going to draw ER here as a orange line. It is going to be in phase with the current, so 75 ohms. ER is equal to 75, not ohms, volts. Okay, and then a nice pink color here for the inductor, 100 volts. It's going to be out of phase by 90. We're going to move it tip to tail. It's going to sit right there. EXL, 100 volts. As you know, the sum of the two is going to be E total, right there. E total. So that's the first thing we're going to calculate, and it will be 75 squared plus 100 squared square root. So I'll calculate that. 75 squared plus 100 squared equals square root. Comes to 125 volts. And that's the answer for A here. Okay. Next thing we're going to do is see if we can calculate the impedance. Now, I don't have any impedance phasors. I could calculate the impedance. Since I know the currents here, I could use Ohm's law to calculate those two, ohms value. But instead, I think I'm just going to use Ohm's law to calculate the impedance because I know that Z is going to be E total over I total. And we just calculated E total. It's 125 volts. I total 1.5 amps. So let's calculate that. 125 divided by 1.5. 83.33 ohms. Okay guys, so now we're going to calculate R. We're going to use Ohm's law. R is going to be ER over IR. ER is 75 volts. IR is 1.5 amps. I mean, all these components are 1.5 amps because it's a series circuit. 75 divided by 1.5, 50 ohms. XL here is going to be EXL over IXL. EXL is 100. IXL is 1.5. 100 divided by 1.5. 66.67. Okay, and now we've done these here, so this is 50 ohms. XL 66. Last thing to do is calculate the phase angle. Phase angle is going to be opposite over adjacent, inverse tan. So the phase angle here is going to be 100 over 75. Shift tan. I'm just calculating it here off to the side. Shift tan equals 53.13 degrees. Okay, guys? And now, the sum of these two should equal 83.33. And we could draw a phasor diagram to prove that, but I'm not going to. But please go ahead and try it. 50 squared plus 66.67 squared should, square root, should equal 83. Let's try it. Z should be 50 squared plus 66.67 squared. Let's try that. 50 squared plus 66.67 squared equals root equals, I'm getting 83.34 ohms, which looks perfect. And you know, those are some things that you can do to check your answers. And there's more than one way to do this question. So if you did it a different way and you got the right answers, that's all that matters. Okay, so signing out, there'll be one more that I'm going to take up in the next video.